Hello, welcome to the day 19 of Advent of Cyber. Let's dive into the story and see what's happening in the city of Wereville and where can we help the elves to celebrate their Sockmas of this year. Diving into the story here. Now the snow falls heavily over the Wereville as the chaos interrupts the best festive company headquarters. What should be the busiest shipping day of the season has turned into a disaster. Another chocolate egg? Shouts a frustrated warehouse worker, holding up yet another Easter themed package. We are supposed to be shipping Christmas presents. The delivery drones buzz overhead. Their mechanical hums sound almost mocking. Each one returns from its route empty, having successfully delivered its cargo. But the cargo is all wrong. You're called into the command center where screens flicker with the delivery statistics. Everything looks normal on the surface. Thousands present in the stock, 98 success rate, and all systems are operational. But the phones won't stop ringing with confused citizens asking why they are receiving chocolate eggs instead of the toys and the gifts they ordered. The logistic manager pulls out a delivery manifest. Look at this, she says, pointing at the screen. The systems indicate that we delivered a teddy bear to Miller family, but they received a chocolate bunny instead. It's the same weight, exact dimensions, but completely different items. Then, on one of the monitoring screens, a message flashes for just a second before disappearing. Exploit version 6.66, property of Hopsec Island. Why should Christmas have all the fun? King Malhare. Someone has compromised the drone's felt systems. The attack is sophisticated, flashifying sensor data, manipulating inventory selection, and erasing all traces. This isn't just a prank, it's a calculated assault on Christmas itself. Your mission is clear. Investigate the best festive company drone delivery system, uncover how King Malhare's exploit team has compromised it, and restore Christmas delivery before Sockmas is ruined. But be warned, King Malhare doesn't leave systems undefended. Traps are waiting for the careless investigator. One wrong move and you might make things much worse. A mysterious delivery. As you walk through the warehouse control room, something catches your eye. A crumpled piece of paper on the floor near the PLC terminal. It looks like someone dropped it in a hurry. You picked it up and unfolded it. The handwriting is hurried, almost frantic. The best festive company drone controller. Register map for maintenance use only. Holding registers HR is HR0 package type selection 012. So I don't know what this is. Maybe it's like the manual for it. 0 is equal to Christmas gift, 1 is equal to chocolate X, 2 is Easter buckets. HR1 delivery zone 1 to 9 normal, 10 ocean dump. HR4 system signature or version default is 100. Current question mark, check this. Coils, boolean flags, okay. C10 is equal to inventory verification, true is equal to system checks actual stock, false is equal to blind operation. C11 means protection or override. True is equal to change locked or monitored. Then normal operations. Okay. C12 is emergency dump protocol. If it is true, it says dump all inventory. If it is false, it says normal. C13 is audit logging. So if it is true, it's all changes are logged. If it's false, no logging has happened. C14 is Christmas restore flag auto set when system correct. And C15 is self destruct status auto armed on breach. Okay. Critical never change HR0 while C11 is equal to true. So C11 if it is equal to true, which is protection or override, change locked or monitored. If it is true, never change 01. Sorry, HR0. So packet selection. Okay, don't change these if it is being monitored or changes are locked. Okay, will trigger countdown. Okay, so that's going to count down a trigger. Maintenance tech, and it's December 19th. Fine. Okay, you stare at the note, confusion washing over you. Register map, coils, what is all this? The terminology is foreign. HR0, C11, mod bus scribbled in the margin, but something about it feels important, like a key you don't yet know how to use. You pocket the note carefully. I will figure out what this means later. You think, for now, you need to understand the systems you are dealing with. Little do you know, this crumpled note will exactly what saves Christmas. Learning objectives. House HADAC systems monitor industrial processes. See, we call it as SCADA. It's basically a system which monitors and controls the all the industrial components. What PLC programmable logic controllers do in automation, how the Modbus protocols enables communication between the industrial devices, how to identify compromised systems configurations in industrial systems, techniques for safely remediating compromised control systems, understanding protection mechanism and trap logics in ICS environments. Connect to the machine. Before moving forward, review the questions in the connection card shown below. Okay, so we need to start the attack box and the VM is there. So let's click on both of them and we can click on check. Let's continue reading. By that time, we can get the machines booted up. So, what is SCADA? SCADA systems are the command centers of industrial operations. They act as a bridge between human operators and the machines doing the work. Think of SCADA as the nervous system of the factory. See, it senses what's happening, processes that information, and sends commands to make things happen. The best festive company uses a SCADA system to oversee its entire drone delivery operations. Without it, operators would have no way to monitor hundreds of drones, manage inventory, or ensure package reaches the right destinations. It's an invisible orchestrator of the Christmas logistics. Components of the SCADA system. A SCADA system typically consists of four key components: sensors and actuators. These are the eyes and hands of the system. Sensors measure real world conditions such as temperatures, pressure, position, and weight. Actors perform physical actions, motors turn, valves open, robotic arms move. The best festive company's warehouse sensors detect when a package is placed on the conveyor belt, and actuators control the robotic arms that load the drones. PLCs, programmable logic controllers. These are the brains that execute automation logic. They read sensors, make decisions based on the programmed rules, and send commands to actuators. A PLC might decide if the package weight matches a chocolate egg and the destination zone 5. Load it on to drone 7. We'll explore PLCs in detail in the next task. Monitoring systems. Visual interfaces like CCTV cameras, dashboards, and alarm panels where operators observe physical processes. Best Festive Company's warehouse has security cameras on port 80 that show real time footage on the packaging flow. These monitoring systems provide immediate visual feedback. You can literally watch the automation is doing. Historians. Database that store operational data for later analysis. Every package loaded, every drone launched, every system change gets recorded. This historical data helps identify patterns, troubleshoot problems, and in incident response scenarios like ours, reconstruct what an attacker did. SCADA and the drone delivery systems. The best festive companies compromise SCADA systems manage several critical functions. Package type selection. The system decides whether to load Christmas gifts, chocolate eggs, or Easter buckets onto each drone. This selection is controlled by a simple numeric value that determines which conveyor belt activates. Oh, okay. So, what we saw here in this note about Christmas gifts, chocolates, and Easter buckets are decimal values which are monitored that. Okay, I get some idea about what that is now. Okay, delivery zone routing. Each package must reach the correct neighborhood. Zone 1 to 9 represents different districts of Wavell, while Zone 10 is reserved for disposal, the ocean, fail safe for damaged goods, but also a perfect target for sabotage. Visual monitoring. The CCTV camera feed provide real-time observation on the warehouse floor. Operators can view which item are being loaded, verify system behaviors, and identify anomalies. The visual layer is crucial during incident response. Inventory verification. Before loading a package, the system can check whether the requested item actually exists in stock. When this verification is disabled, the system blindly follows commands, even if those commands are malicious. Systems protection mechanism. Security features designed to prevent unauthorized changes. When enabled, these protections monitor for suspicious modification and can trigger defensive responses. Unfortunately, King Malhare has weaponized these very protections as part of his trap. Audit logging. Every configuration change, every operator login, every system modification should be recorded. Attackers often turn off logging to cover their tracks, and that's precisely what happened here. Why SCADA systems are targeted? Industrial control systems such as SCADA have become increasingly attractive targets for the cybercriminals and the national state actors. Here's why. They often run legacy softwares with known vulnerabilities. Many SCADA systems were installed decades ago and never updated. Security patches that exist for modern softwares doesn't exist for these aging systems. Default credentials are commonly left unchanged. Administrators prioritize keeping systems running over changing passwords. In industrial environments, the mentality is often if it works, don't touch it. A recipe for security disaster. They are designed for reliability, not security. Most SCADA systems were built before cybersecurity was a significant concern. They were intended for closed networks that were presumed safe. Authentication, encryption, and access controls were afterthoughts at best. They control physical processes. Unlike attacking a website or stealing data, compromising SCADA system has real-world consequences. Attackers can cause blackouts, contaminate water supplies, or in our case, sabotage Christmas deliveries. Thus, often connected to corporate networks, the myth of air-gapped industrial systems is largely fiction. Most SCADA systems cannot connect to business network for reporting, remote management, and data integration. This connectivity provides attackers with entry points. Protocols like Modbus lack authentication. Many industrial protocols were designed for trusted environments. Anyone who can reach the Modbus port 502 can read and write values without providing their identity. In early 2024, the first ICS or OT malware, Goop, was discovered. The malware can directly interface with industrial control systems via the Modbus TCP protocol, enabling arbitrary reads and writes to device registers over TCP port 502. King Malhar has weaponized these same techniques, not to cause blackouts but to sabotage Christmas delivery by directly manipulating the control system through the Modbus protocol. In this next task, we will explore PLC, the component he's actually compromised. Oh, that's good. Okay, so we have a question to answer. It says, what port is commonly used by Modbus TCP, which is 502. Click on check and move to the next section of this task today. Let's close all these. Okay. What is a PLC? A PLC, Programmable Logic Controller, is an individual computer designed to control machinery and process in real world environments. Unlike your laptop or smartphones, PLCs are purpose built machines engineered for extreme reliability and harsh conditions. PLCs are designed to survive harsh environments. They operate flawlessly in extreme temperatures, constant vibrations, dust, moisture, and electromagnetic interference. A PLC controlling warehouse robotics might endure freezing temperatures in winter storage areas and scorching heat near packaging machineries. Run continuously without failure. PLCs operate 24 bar 7 for years, sometimes decades, without rebooting. Industrial facilities can't afford downtime for software updates or system restarts. When a PLC starts running, it's expected to keep running indefinitely. Execute control logic in real time. PLCs respond to sensor inputs within milliseconds. When a package reaches the end of the conveyor belt, the PLC must instantly activate the robotic arm to catch it. These timing requirements are critical for safety and efficiency. Interface directly with physical hardware. PLCs connect directly to sensors, measuring temperatures, pressure, position, weight, and actuators, motors, valves, switches, robotic arms. They speak the electrical language of industrial machineries. What is Modbus? Modbus is communication protocol that industrial devices use to talk to each other. Created in 1979 by Modonic, now Skinder Electric. I'm sorry if I'm butchering the name. I'm not able to pronounce it. Okay. It's one of the oldest and most widely deployed industrial protocol in the world. Its longevity isn't due to sophisticated features. Quite the opposite. Modbus succeeded because it's simple, reliable, and works with almost any devices. Think of Modbus as a basic request response conversion. Client, your computer. PLC, what's the current value of the register 0? Server, PLC, register 0 currently holds the value 1. This simplicity makes Modbus easy to implement and debug, but it also means security was never a consideration. There's no authentication, no encryption, no authorization checking. Anyone who can reach the Modbus port can read or write any value. It's equivalent of leaving your house unlocked with saying, "Come in, everything is accessible." Modbus data types. Modbus organized data into four distinct types, each serving a specific purpose in industrial automation. Type, it's coils, discrete inputs, holding registers, input register. So the purpose of coils is to digital inputs on or off. Values are 0 or 1. Example use case, monitoring running, motor running, valve open, or alarm active. Then discrete inputs, digital inputs on or off, 0 or 1 is the values. Button pressed, doors closed, sensors triggered. Okay. Holding registers, analog outputs, it's numbers 0 to 5, 65535. Temperature, set point, motor, speed, zone selection. Then comes input registers, analog inputs 0 to 65535. These are basically the values that it can hold. That's the range of values. And the example use case is the current temperature, pressure, reading, and flow rate. Okay, so basically, these are the types of data that Modbus can hold or show us. Okay. Again, I'm reading this for the first time. I'm not familiarized or hands-on with PLCs and all these things. So it's a new thing that I'm also reading for the first time. I am going in a very slow manner for that reason. The distinction between the inputs and output is important. Call and holding registers are writable. You can change their values to control the system. Discrete inputs and input registers are read only. They reflect sensor measurements that you observe but cannot directly modify. The best festive company's drone control system, you will find holding registers, storing configuration values, HR0. Oh, these were the things. Okay, in the sheet up here. Okay, so these are all the holding resistors, and these are Boolean flags, basically the coils. So these are only read only kind of values, and these are modifiable. Okay, get it. I get an idea of it. Okay, let's continue reading from here. In the best festive company's drone control system, you will find holding registers storing configuration values. HR0 package type selection. It is 0 for gift, 1 for X, 2 for basket. And HR1 delivery zone from 1 to 9 for normal zones, 10 for emergency disposal. HR4 system signature, a version identifier, or in this case, an attacker's calling card. And coils are controlling system behaviors. Inventory verification enabled or disabled, protection mechanism enabled or disabled, emergency dump protocol active or inactive, audit logging enabled or disabled, Christmas restoration status flag, then self destruct mechanism armed or disarmed. Remember that crumbled note you found earlier? Now it makes complete sense. The maintenance technician was documenting these exact Modbus addresses and their meanings. Yep, yep, we see that. Modbus addressing. Each data point in Modbus has a unique address. Think of it like a house number on a street. When you want to read or write a specific value, you reference it by its address number. Critical detail. Modbus addresses start at 0, not 1. This 0 indexing catches many beginners off guard. When documentation means means register 0, it literally means the first register, not the second. Examples from best festive company: holding register 0, HR0, package type selector; holding register 1, HR1, delivery zone; holding register 4, system signature; coil 10, which is C10, inventory verification flag; coil 11, C11, protection mechanism flag; and coil 15, its self-destruction status. Modbus TCP versus serial Modbus. Originally, Modbus operated over serial connection using RS-232 or RS-485 cables. Devices were physically connected in a network, and this physical isolation provided a degree of security. You needed physical access to the wiring to intercept or inject commands. Modern industry systems use Modbus TCP, which encapsulates the Modbus protocol inside a standard TCP IP network pockets. Modbus TCP servers listen on port 502 by default. This network connectivity brings enormous benefits: remote monitoring, easier integration with business systems, and centralized management, but also exposes the historical isolated system, the network. King Malhare exploited exactly this vulnerability. The best festive company drone systems Modbus TCP port 502 was accessible over the network without any authentication required. He didn't need to break into facility or tamper with the writing. He simply connected to port 502 and started issuing commands as if he were authorized. The security problem: Modbus has a no built-in security mechanism, no authentication. The protocol doesn't verify who's making requests. Any client can connect and issue commands. No encryption. All communication happens in plain text. Anyone monitoring network traffic can easily see exactly what values are being read or written. No authorization. There is no concept of permission. If you can connect, you can read and write anything. No integrity checking. Beyond basic sum check of transmission errors, there is no cryptographic verification of the commands haven't been tampered with. Modern security solutions exist: VPNs, firewalls, Modbus security gateways, but they are add ons, not part of the protocol itself. Many industrial facilities haven't implemented these protections, either due to cost concerns, compatibility issues with legacy equipments, or simply lack of awareness. Connecting the dots. Now you understand why OpenPLC web interface showed nothing useful. King Malhar bypassed it entirely. He connected directly to the Modbus TCP port and manipulated the resistor and coils that control system behavior. That node you found, the maintenance technician must have discovered what was happening and started documenting the compromised values. The warning at the bottom, never change HR0 while C11, is true, suggests they figured out the trap mechanism before getting interrupted. In the next task, we will use Python and PyModbus library to investigate the system exactly the way King Malhar attacked it. By directly reading and writing the Modbus values, time to see what he actually changed. Now that you have understood how the system works, the mission is yours. Hack it back and save Christmas. Let's click on check, then go to the practical section of this. Oof, this has been actually very long and but interesting at the same time too. Okay, so we have a lot of stuff in there and a lot of commands in there. So I will reduce the screen size so that we can see it better and read it better. Here we go. Now that you have understood the basic concept related to ICS and Modbus, we will analyze the compromise, the best festive company drone control system, and learn how to safely restore it. Initial reconnaissance. As with any incident response scenarios, we begin with reconnaissance. Let's discover what services were running on the target system. For the attacker's terminal, run nmap scan. We are starting with the nmap scan here. Let's open the terminal and scan with the command nmap, then -sv -p. So -sv is going to show the versions of the services that is running. Let's open a nmap help tab. Then let's run the nmap commands. So -sv is going to talk about what are the services and the versions related to them. So we can see this switch here. It says probe open ports to determine service versions and information. So that's the one. Then -p is we are specifying what ports to exactly scan into, and we can see that right here. We can specify the set of ports that we want to scan by giving the comma in between. Then we have mentioned the target IP to scan for. Okay, so let's start the nmap scan here. So -sv -p port 22 we want to scan, then 80, then comes 502. Port 22 is basically for any SSH services that is running in a system. If you want to connect to it, port 22 is the one. Port 80 web interfaces usually, but I remember here somewhere they said that port 80 is being used for some other cases or some other protocol. I don't remember what protocol it was, but it is mentioned somewhere there. So we want to check for that, as well as port 502, which is the Modbus or their applications port number there. So let's scan for that. Now for that, we should also mention the target IP address. So 10.48.174.182. Then let's click on enter. That should start scanning for the open ports that is specified here. Let's continue reading, and as we get the results, we can compare them. Note we specified ports 2280 502 to speed up the scan. If you want to perform a comprehensive scan of all ports, you can use P and hyphen, which is going to scan entire from 00 to 65,000 some port number. It's going to scan for the entire thing. And the specification of T4 is nothing but it's going to make the scans rate into a faster rate. So we have till T5 also. It's going to just make the scan really fast. -VV is going to show a verbose output of it. Fine. Anyway, we have an output here. So let's continue reading. We can just compare the output from here again. However, this will take significantly longer, several minutes, as it scans all the 65,535 ports. Key findings. Port 80, it's hosting a HTTP service, the CCTV camera feed. Okay, yeah. So it was hosting a CCTV camera feed. And in general, port 80 is going to be for any web application. If you're hosting a simple HTTP website, it's going to be hosted on port 80 by default, unless you want to change it in any other port number. So here they're hosting a HTTP service for the CCTV camera. Then port 502 is the Modbus TCP. It's a PLC communication protocol that is running on these two ports. We get an output here. From the result, this is nothing but the signatures and fingerprints, which is fine. We can see that we have port number 22, the first one, and it is open SSH. So we can see that it is running an SSH service. If we want to, we can connect it with the right credentials. Then we get the works something. It's basically hosted using Python 3.1.3, and it is hosted on port 80. Then 502, it's MBAP. So this has not clearly been able to find out what exactly it is hosting. Nevertheless, we get that these three ports are open. Let's continue reading here. This is typically of an industrial control system setup, a web interface for monitoring and Modbus for programmatic control. Visual confirmation, the CCTV feed. Before diving into the technical details, let's see what's physically happening in the warehouse. Navigate to this IP in your browser. Let's copy this IP and paste it in the clipboard here. And let's open Firefox. While that's opening, yeah, it's opened. Let's paste in the IP address here. Okay, it says status compromise and it says disarmed. Okay. Oh, these are some nice AI generated video of a factory. And we can see a suitcase probably which has X in it, and also right here. And some boxes are also there in the wheel or that thing that is there. Okay, through the security cameras, you can see the warehouse floor in real time. Robotic arms are busy at work. The conveyor belts are running smoothly, but something is wrong. Instead of the Christmas presents, you see a pastel colored chocolate eggs being sorted. Yes, we can see that here, that it's colored eggs. And Easter themed packaging on the assembly line. They are Easter themed. And delivery drones are loading eggs instead of gifts. Yeah, gifts are on the belt itself, but the drones are fed with the eggs there. The status displayed in the corner shows compromised. We can see that here. It's the visual confirmation of it. The visual confirmation tells you the problem is real and active. The system isn't broken, it's working perfectly, just delivering the wrong items. This is a classic sign of logic manipulation attacks rather than a systematic failure. Keep the CCTV feed open on a separate tab. It will update as you make changes on the system, providing real time feedback on your remediation efforts. Okay? Modbus reconnaissance. We will need to interrogate the Modbus servers directly. This is where Python and PyModbus library becomes essential. Remember that crumbled note you found earlier? Put it out now. The terminology that seemed foreign, HR0C11, Modbus, is about to make perfect sense. Note the step 1 to 5 are optional and you can just read them along with. So steps 1 to 5, I guess this is all installed earlier. So we don't have to do it, but we'll just continue reading it. On the attack box, we have already pre-installed it, but if you're using your own machine, you need to ensure that you have the necessary library installed. pip3 install modbus is equal to 3.6.8, and that downloads it. Then step 2 is to establish connections. Let's connect the PLC's modbus interface, open a Python interpreter, then paste all these commands here. It says from the library that just you have downloaded. It's going to use that library, which is pymodbus.client. Import this module. So then connect to PLC on port 502. So we are establishing a variable called client, which uses Modbus TCP client function for specifying what is the IP address and the port number. Then comes establish connection. So if client.connect, it's basically connecting using these IP address and the port number. And if it says print connected to the PLC successfully, else if it doesn't connect, it's going to print connection failed. Then the output is connected to PLC successfully. Okay, that's done. Then excellent, we have a connection to the PLC's Modbus interface. Notice how no authentication was required. This is a critical security weakness in the Modbus protocol. Reading holding registers. Holding registers store numeric configuration values. According to the note, HR0 controls the package type selection. Let's read it. So again, the Python code says result is equal to client dot read. These are the same variables which is established earlier. So you can just continue typing in the same terminal there. So it's going to use the variable client, which is declared here. Then it's going to read holding register address is equal to 0, count is 1, and slave is 1. I don't know what these are, but some values there. If not, result dot is error. That means if there is no error in it. Package type is equal to result dot register 0. It's basically a list that it is opening up, and it says printf HR0 package type, what type of package is being loaded. And if package type is equal to 0, it's going to print Christmas present. Again, basically it's checking what kind of package is being shipped in, or which packet is being stored there for the value to be shipped to the customers. So we are reading those values which is held in the registers there. And it says chocolate X. Okay, so it says that HR0 is holding 1, and we can also see that value there. There it is. HR0 is set to 1, which means that the system is configured to load chocolate X. The note was right. This is exactly what's causing the problem. Let's check HR1, the drone delivery zones. Result is equal to client dot reading holding. Again, the same thing is there. The only difference is this time we are reading the address 1, and rest all the points are 1, and slave is also 1. I don't know what exactly it is, but we are reading the second thing right now. If not, again error, then it's going to check for what zone is it, and it is going to show a warning if it is an ocean dump, and it's going to show normal delivery if it is a normal delivery, depending upon the number there. So if it is 10, it's going to show ocean dump. If it is not 10, it's going to deliver. And it says normal delivery zone, so it is, the value is 5 there. That's the reason customers were getting the X instead of the teddies or whatever content they had asked for. Okay, so zone 5 is normal. Now let's check HR4, the system resist signature. We are looking for the address for that. Then, oh, these numbers are based upon what HR we are looking at. So this is HR4, this was HR0. No, this was HR1, so it's 1. Okay, so we are reading the addresses of those. I get it. Okay. So now we are checking to see what is the signature of this, and we get that it is exploit detected. King Malhare's signature. So King Malhare has compromised it, and King Malhare's signatures are being found there. Okay, that's good. So the value 666 confirms the system has been compromised by the exploit framework. This matches the taunt message we saw earlier, exploit version 6.66. Step 4, reading coils. Coils are Boolean flags that control system behavior. The noted mentions several critical coils. Let's read them. We are reading the 10th one. So this is, let's just read the output. It says C10 false, which means inventory verification. Is the inventory that is being loaded on, is it being verified? It says false, means that disabled systems are not checking the stock. Okay, so that's a critical failure. Inventory verification is disabled. The system is blindly following commands without checking if items actually exist in stock. Let's check C11. And in C11, we get that it is true, which is the protection or override. So if it is true, which means that changes are being monitored. Well, so the protection is there, that it is going to look after if there is going to be any changes which are being done. So it's being monitored, which is a good thing, but in the wrong context. So if we as the defenders try to change something, there are other clauses which are there for self-destructing. It's going to start because they're being monitored, and that's going to be a wrong thing. So the operation is good, but it's going to play back against us if we try to modify or try to do anything with it. It's crucial. C11 is enabled, which means that the system is actively monitoring for changes. Remember the warning on the note, never change HR0 while C11 is true, will trigger countdown. Let's check if the self-destruction is already armed. And we can see it says false, so not armed yet, safe for now, which means that there is no self-destruction which is going to happen. Good news, the self-destruction isn't armed yet, but it will be if we try to change HR0 while C11 is active. This is the trap mechanism. Now, step 5, understanding the trap. Now, the note makes complete sense. The maintenance technician discovered HR0 is set to 1, forcing X. C11 protection is enabled, monitoring for changes. If anyone changes HR0 while C11 is true, C15 gets armed. Once C15 is armed, a 30-second countdown begins. After 30 seconds, C12 emergency dump activates and everything dumps to the zone 10, which is the oceans. The technician's warning was trying to save whoever found this note from making things worse. Complete reconnaissance script. Let's create a comprehensive script to see the full system status. Exit the Python interpreter, press Ctrl D or type exit, then create a new file. So we'll start doing this now. So let's do nano. Then reconnaissance.py. We are creating a new file called as reconnaissance, which is a Python file. Now let's just copy and paste the following code. all these things. I'm not exactly reading them because it's too big, and I feel the video has also gone a lot long. So let's understand it while the code executes. Let's paste that code right there, and with let's exit. Yes, so press on Control X, then Y, then press enter. That's going to exit from the nano editor. Now it says Python 3 reconnaissance.py. So we're executing the script here. So let's run Python 3, then reconnaissance.py, press enter. That runs the script there. So we see the best festive company drone system reconnaissance report. Holding register HR type is set to 1, which is 1 is X. Delivery zone is set to 5, which is 1 to 9 is normal zones. Then HR4 is set to 666, which is the exploit, which is the King Malhare signature. Then coming to the coils, we see C10 to be set to false, which means that there's no verification of the inventory monitor. So this should be set to true. C11, it's going to say if there's any protection or override of it. It says true, which means that the system is being monitored for it. Then C12 is an emergency dump, which is set to false. So right now there is nothing to be alarmed about it. C13, it's an auditing log. False should be true, which means it's going to look for any changes that is being done. Then C14, Christmas restored is false. Auto set when system is fixed. Okay, then comes C15, which is self-destruct armed, which is false right now. So threat assessment, exploit framework detected, protection mechanism is active. It's a trap which is set. Then package type force to X, inventory verification disabled, audit logging disabled, and remediation required. Okay, you know what is happening? I'm getting a curious thought of trying to modify and see what's going to happen, like without the security checks. I just want to try. I After this is done, I want to try that. Okay, so let's continue reading. uh, Safe remediation. Based on our reconnaissance, we need to disable the protection mechanism C11 first. Change the package type to Christmas gift HR0. Enable inventory verification to true. Enable audit logging. And verify C11 never got armed. The order is critical. If we change HR0 before disabling C11, the trap triggers. Create the remediation script. But my intrusive thoughts are to change it without without disabling what needs to be disabled. So again, let's do it after we finish this task. So now let's copy the code which is here. I guess this is to read and write itself. So let's copy it, paste it there, then dump it here. Okay, so I guess that is it. So let's click on Control X, Y, and enter once again to exit out of the nano editor. Now let's run this script again. So Python 3 restore Christmas.py. So the best festive company system, Christmas restoration. Step 1, verifying the current system status. Package type is set to 1, which is X. Protection active, true. Self-destruction armed, false. Step 2, disabling protection mechanism. Protection disabled, safe to proceed with changes. Step 3, setting package type to Christmas presents. Package type change to Christmas present. Type 4, enabling inventory verification. Inventory verification enabled. Step 5, enabling audit logging. Audit logging enabled. Further changes will be logged. Verifying system restoration. Package set to 0. Okay, so yeah, and we get the flag also. Excellent work. Now that we check the CCTV feed, let's look at the CCTV feed that we have. Huh? We get King Malhare here. Okay. Wow. I was not expecting this though. But anyway, fine. You see King Malhare's defeated displayed. Yeah. What if you trigger the trap? Oh wow, this is exactly here. If you had tried to change HR0 before C11, here's what would have happened. The would arm immediately. 30-second countdown would begin. After 30 seconds, C12 emergency would activate. HR1 would change to 10, which is ocean dump. All remaining inventory would be dumped. The CCTV would show a trap activation screen. You would need to restart the challenge. The demonstration why understanding the industrial control systems before making changes is crucial. In real world scenarios, triggering safety mechanism or traps could have severe physical consequences. Okay, so post incident analysis. King Malhare's attack was sophisticated because it used unauthorized Modbus access, port 502, manipulated configuration values directly at the protocol level, disabled safety mechanisms, verification, and logging, implemented a trap to prevent easy remediation, left a signature 666 as calling card. The maintenance technician who left the note likely discovered the compromise but was interrupted before they could fix it. Their documentation saved Christmas by warning about the trap mechanism. Congratulations, you have successfully investigated and remediated the industrial control system compromised. You have learned how SCADA systems work, learn how PLCs operate, how Modbus communication functions, and most importantly, how attackers can manipulate these systems and how safely to restore them. That's nice. So let's submit the flag and let's do what our intrusive thoughts were telling us to do. Let's copy it from the clipboard here, paste it in there, click on check. That's done. Yes, we enjoyed the room. Now, let's click on continue, close. Okay, so I'll put this as a YouTube short itself. I think the video will get too long if I just continue here. So yes, thank you for watching. Let's meet you all on the day 20th of Advent of Cyber. Thank you for watching. Stay happy, stay smiling. Bye-bye.